guy named Bubba. He's going to buy tickets to the Justin Bieber concert. You with me so far?
No.
The cost of each ticket depends on how many tickets Bubba buys. Sometimes you go to a place and it says, they'll say the more tickets you buy, the better price you're going to get. You ever did something like that? Like those travel bugs I bought, which you guys still owe me things for. I have things from you, don't I? From anybody in this class?
I can't find anything small to put on. I threw all most of my small stuff away when.
All right, well, we'll get to it later. But with those travel bugs, the more travel bugs I bought, the better price I got. Because we bought 30 of them, they were cheaper than buying individually. All right? So, anyway, this thing right here, we're going to answer a bunch of questions. I'm just going to go back and forth, makes it a little smaller so maybe we can see some of it. All right. Let's do this part of this together. All right. This question number 1, when is that graph increasing?
It's decreasing.
So it's never increasing. So the answer number 1, it's never increasing. Go ahead and write that down. It's never increasing. All right. When is it decreasing?
Always.
All right. It's always decreasing. It's always decreasing. Number 3 asks, are there any turning points? Remember what turning points were? Okay, turning point, Mike, will be something like this.
Yeah, I know you showed me yesterday.
Okay, so that's a turning point. Are there any turning points in that one?
No.
No, not really. There are none. So a lot of this is a lot of nothing right now. So you guys seem to, you did well on this yesterday. If I move this down, you guys can be okay with it? And you'll get it? Michael, do you have it written down? The first 3. Okay. Number 4. When is the graph positive? Remember, it's positive if it's above the x-axis, above the 0 on the x-axis.
So always?
Yeah, it's always positive. This means it's positive. If it were below, then it would be negative. So, when is it positive? Always. When is it negative, Steve? It's never negative. All right, number 6. What is the maximum? What's the highest point on there? And you're going to have to write this in your blanks. I can't go back and forth. 120, that's sort of right. What's the other part?
140.
Taiwan's right. The maximum is, this is the maximum, isn't it?
Oh, yeah.
And you would read that as 1 in 120. How did that last class? What was the question with number 5?
Never.
It's never negative, right? So the maximum is this right here. And that's at 1 ticket will cost you $120. Right? We mostly call this 1 in 120, but this really 1 ticket is $120. Already got that? Steve, when is the minimum? 0 is the minimum? No.
9, 40.
Right, 9 and 40. This is the minimum. 9 tickets cost how many dollars each? $40 each. So that's the minimum. Make sure you understand that you'll be doing this on your own very shortly. Number 8. Is this continuous or discrete?
Oh, continuous.
Continuous. One person says continuous. Look back at your notes. Open up the notes that say geometric, I think it's geometric behaviors of functions. It's why is it discrete? Don't just make it. No, it is
It's
discrete.
concept.
That's a lie. It's discrete because all the points are separated. Because each point is separated, that means it's discrete. Hey guys, if it looked like this, if I gave you a curve then that would be continuous. This is discrete. And it's discrete because all the points are separate. Got it?
Wait, what was the, you just say?
That was number 8. It's discrete because all the points are separate. And if you take a look here,
I can spell together.
so what word?
Together.
T-O-G,
Okay.
E-T-H,
Okay.
E-R.
Thank you.
Here's the discrete. If you can sell 6 tickets, can you sell 6.5 tickets?
Yeah.
You can't have a half person. It's either 6 or 7. It's nothing in between. But certain other things with time and speed and money, you can have all those little degrees in between. All right, number 9 asks you, what's the domain of that? First of all, what does domain mean?
The y-axis.
I'm going to go with what Jacob said, the x's. You did, I thought you said the y. So, what are the x's?
Yeah.
What are they? What are those numbers? Specifically, what numbers are in the x's? So what I want you to answer this question, write only ordered pairs. This ordered pair here is 1 and 120. This ordered pair is 2 and 100. Right next to the point. 1 comma 120, 2 comma 100. Write them all in there.
So write that down.
Yes.
That means number 9?
The ones that's for the domain?
Yeah, that's number 9.
Yes.
You write down.
I want you to write down the order pairs on the graph. We'll list the domain in a second. So we know what the
Yes,
X
write down the screw, right?
Uh-huh.
In the domain.
No, I want you writing on the graph itself. And then we'll list the parts of the domain in a minute.
What? No, you say that louder? This is recording?
All right, now that you have all the points down, hey, Juan and Steve, what are the members of the domain? What are all your x's?
1, 2, 3, 4, 5, 6, 7, 8, 9.
So in number 9, where it says what is the domain, you're going to list it. I don't want you writing it 1 through 9. Write it like this. Something like that. Just list them all. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's your domain. All right. So that's what they are. You have to just list them all. Okay, Juan, what's number 10 that are you still writing about?
Huh? I'm not going number 10.
All right, number 10. Go ahead. Number 10 asks if there is a restriction on the domain. You guys know what restriction means from last time?
You really messed up the graph.
That doesn't mess up the graph.
Like, it's not looking right.
I'm gonna move this.
No way.
Are there any members of the domain, are there any x's that can't be on there?
No, excuse me.
Well, anything less than 1, are there any numbers less than 1 in the domain?
No.
Are there any numbers greater than 9?
Yes.
Well, we're given what we can see. So the restriction are there's nothing less than 0 and nothing more than 9. So write that down. So what are the restrictions on it? Nothing less than 1 and nothing greater than 9. N-O-T-H. I-N-G. All right. Number 11 asks what is the range? So the range is asking for the y's. So next to number 11, just list all your y's. 120, comma, 100, comma, 80, 70, 60, 50, and what's that?
100.
Yes. It's just all these numbers. It's just those numbers. All right. If you have, everybody have these? All right. Last three are easy. Oops. What's the y-intercept? Where's it cross the y-axis?
That's 0.
Okay. Here's the y-axis. Does it cross the y-axis?
No.
No. So there is no y-intercept.
So
They
no.
write none for that one. I think it's number 12, is it? What is the x-intercept? Where does that cross the x-intercept?
None.
Right, it doesn't cross the x-intercept.
It does. No.
It does. Well, it doesn't.
So none.
That's right, there's none, again. And the last question, number 14, asks, is the rate of change constant?
No.
No. The rate of change is not constant. All right.